Welcome. In this video, we will cover Chapter 20, Household Chemicals. All over society, chemicals are used within the household to improve qualities of life. One of the most common applications of chemicals in the household is cleaning. Some simple chemicals from plants, such as soapworts or soapberries, contain saponins, which can produce a soapy lather. This can be used in conjunction with beating clothes against rocks. In other places, wood ash is used, which contains potassium and sodium carbonate. These will form alkaline solutions in water that have some detergent properties. Sodium carbonate is still used today as washing soda. Let's go through the chemical reaction that occurs when soap is formed. On an industrial scale, soap is made from reacting animal fat or vegetable oil with lye. We can see the structure of fat, which contains this ester linkage. This oxygen, 3 times bound to a glycerol backbone, forms the structure of fat. When this is reacted with sodium hydroxide, the oxygen-carbon bond is broken, and that forms the soap and liberates the glycerol backbone. Soap has a unique structure where half of the molecule is hydrophobic, or water-repelling. This is a nonpolar portion that contains no oxygens or nitrogens, no atom that can hydrogen bond. And the other half of the molecule is hydrophilic, or water attracting. This half contains an oxygen with a negative charge and a sodium with a positive charge, or an ionic head. This means that half of the molecule can react with nonpolar and half of the molecule can react with polar. What then occurs is the production of a micelle. A micelle is a spherical structure, and on the inside of the sphere, all of the nonpolar portions of the soap can trap a molecule of oil, or a droplet of oil. Then all of the polar portions line up on the outside of the sphere, and these can interact with the water. When you mix oil and water, you observe that they don't mix well together. They're not miscible. But what the micelle allows is the oil to get trapped inside the sphere of negative charges on the outside and then become soluble in water. What results is an emulsion, with the soap acting as the emulsifying agent. This is going to allow nonpolar substances to become soluble in a polar solvent, such as water. If you've ever let a glass of water sit on your nightstand and evaporate over time, you might have noticed a white film that'll start to occur on the outside of the glass. This is evidence of hard water. Hard water, often tap water, contains high concentration of minerals such as calcium, magnesium, and iron. These ions will react with the soap and basically precipitate out the soap, reducing its effectiveness. This is one of the disadvantages of soap and why it's necessary to use, in some cases, detergents. Depending on the quality of the tap water, in many houses, a water softener is necessary. A water softener will use an additive such as soda ash or trisodium phosphate that will raise the pH of the water and precipitate out these ions. A water softener can replace the calcium and magnesium ions with sodium ions, which will be less detrimental to the soaps and detergents. These water softeners are very common in households that contain a natural source of hard water. They soften the water and reduce the concentration of these minerals. Just like we have the ability to synthesize drugs in the laboratory, we also have the ability to synthesize detergents. During World War II, raw materials for soap production became very scarce, and a variety of synthetic detergents were developed with a similar mechanism of action to that of soap. For example, this molecule here has the left side, which is hydrophobic, and the right side, which is hydrophilic. This will allow a similar formation of micelles without the negative effects of hard water. Several different types of synthetic detergents have been produced. ABS detergents are non-biodegradable. These alkyl benzene sulfonate detergents produce a foam that appeared on natural lakes and rivers over time in areas where they were used. These were banned eventually and replaced with biodegradable detergents that have less negative environmental impacts. This figure illustrates some of the buildup of these ABS detergents, both in river and lake settings as well as within tap water. New technology allowed for the creation of linear alkyl sulfonate detergents that have linear chains of carbon atoms. These linear chains can be broken down by microorganisms and cleaved into smaller chains, which eventually allows the molecule to degrade. Detergents are also used to clean clothes. These detergents are often a cocktail of a variety of chemicals, each designed with specific functions to help clean the laundry. This is a little bit more complicated than just the dish detergents. We can classify the compounds that are used to produce detergents into three categories: surfactants, builders, and brighteners, each with its own function. Surfactants emulsify the soil and oils. They can be either anionic with a negative charge, cationic with a positive charge, non-ionic with no charge, or amphoteric with multiple charges. Amphoteric surfactants are zwitterions. They carry both a positive and negative charge. For example, betaine has a nitrogen with a positive charge as well as an oxygen with a negative charge. This allows them to react with a more diverse variety of chemicals. Builders are an additive used in the detergent formula to increase the detergency of the surfactant. For example, sodium citrate, sodium tripolyphosphate, and sodium hexametaphosphate are used to help sequester calcium and magnesium ions, removing them from the solutions. This is acting in a similar fashion to the water softeners that were used to remove hard water. And then finally, brighteners are added to the detergent formulations to make clothing appear bright and new. This helps with the color of the clothing. Dishwashing detergents for automatic dishwashers are usually strongly alkaline or basic. They contain molecules like sodium tripolyphosphate, sodium carbonate, sodium metasilicate, and bleach, along with the surfactant. Bleaches are oxidizing agents that react with colored stains on fabrics. The most common bleach, or household bleach, is sodium hypochlorite, NaOCl. Other bleaches exist, such as sodium percarbonate or sodium perborate. These bleaches work by liberating hydrogen peroxide in hot water, which is the active oxidizing agent. A variety of other chemicals are used as household cleaners. For example, acetic acid or vinegar is commonly used as a cleaning product as it can help kill mold. So this is used in areas where mold could be a potential issue. Many household cleaners for kitchen areas include ammonia chloride solutions. One note that's important when thinking about household cleaning products is that there are some products that don't mix well together. For example, household bleach or sodium hypochlorite and ammonia chloride can react together to form chlorine gas. We also have special purpose cleaners, including highly acidic or basic materials such as toilet bowl cleaners to remove calcium carbonate deposits, glass cleaners using isopropyl alcohol and ammonia or vinegar, and scouring powders that contain silica oxide, which can help to polish different materials. If you've ever used Drano, Drano is basically a solution that contains a high amount of sodium hydroxide, and this works by saponifying any grease that has clogged up the drains. There are many different solvents. The most common one in the household is water, which is a polar solvent, but there are also several non-polar solvents that would be commonly found in the household. These are called organic solvents, and they're used for functions such as removing paint, adhesives, and wax. Organic solvents generally have a lower boiling point than polar solvents, and they're volatile and flammable. The most common organic solvent in the household is generally acetone, which is used as a nail polish remover. Paints include a wide variety of chemicals, some of which are oil-based and some of which are water-based. They're composed of three basic ingredients: the pigment, which gives it coloration, a binder, and a solvent. Similar to the fatty acids used to form soap, waxes are also esters of long-chain fatty acids and long-chain alcohols. For example, paraffin wax is a mixture of long-chain hydrocarbons. These serve as protective coatings for both plants and animals, and a variety of other household functions such as car wax and candles. The cosmetic industry is one of the largest industries that uses applications of chemicals within the household. A cosmetic is defined as any chemical that's intended to be applied to the human body for cleansing, beautifying, or promoting attractiveness or alternating appearance. The level of regulation for cosmetics is significantly lower than the level of regulation for drugs. Skin creams and lotions are applied to the dead cells of the corneal layer of the skin and have a variety of different functions. A lotion is an emulsion of oil droplets dispersed in water, and a cream is an emulsion of water droplets dispersed in water. These will form a protective layer over the skin that helps to retain the moisture. The mechanism of these are fairly different from each other. Emulsions protect the skin by coating and softening it. Moisturizers will hold moisture into the skin, whereas humectants will actually pull water from the atmosphere and attract it towards the skin. One of the most common lotions is sunscreen lotion. This works by blocking short wavelength UVB radiation and preventing that radiation from harming the skin. The original formulation for sunscreen lotions used para-aminobenzoic acid, which is water soluble. If you've ever heard the saying about waiting a certain amount of time before going into the water, that originated because the first sunscreen lotions would actually just dissolve right into the water. They were water soluble. In recent years, newer formulations contain octyl methoxycinnamate, which is insoluble in water. This allows the lotion to have a higher level of effectiveness when used in conjunction with swimming. Deodorants and antiperspirants also contain chemicals. These contain perfumes used to mask body odor and germicides used to kill bacteria. Toothpaste is a cosmetic product with a direct link to health. And it's probably one of the most important cosmetic products that exist in the household. It's composed of a detergent and an abrasive, as well as flavoring or coloring agents and thickeners. Every chemical has a unique smell. Some of those smells might be undetectable by humans, but many chemicals do have smells that are detectable by humans and are either quite pleasant or non-pleasant. Perfumes and colognes generally contain pleasant smells. These are also fairly volatile so that the smell will travel from where the perfume or cologne was applied. Table 20.2 shows the structure of some molecules that and the particular odor which they exhibit. If you notice, many of these contain the aldehyde functional group, which is a carbon double bonded to an oxygen with the hydrogen attached. Shampoos contain a detergent, such as sodium dodecyl sulfate, as well as coloring agents. Conditioners are mainly long-chain alcohols or quaternary ammonia salts that coat the surface of the hair and allow the strands to slide past each other. They almost form a small protective layer. Within the hair proteins, there is a disulfide bond. This is two sulfurs bound together. Perms are accomplished by breaking this disulfide bond using specific lotions that have thioglycolic acid. The hair can then be curled on rollers and treated with hydrogen peroxide to re-establish new disulfide linkages. But now, instead of the sulfurs directly across from each other being linked, the sulfurs are linked in a different manner, forming the new hairstyle. When choosing which household product to use, it is important to understand the chemistry that is occurring using that product. Each product is going to contain a different variety of chemicals which have different functions and purposes. A well-informed consumer will understand what the purpose of some of these chemicals and how they differ from each other.